All right, so today we're talking about infinite series, the ones that go on to infinity. So when do they converge? When do they diverge? All that kind of stuff. If they converge, what do they converge to? So a note of different notation and vocabulary. A sequence is your list of numbers. That's your ace of n. A series is a sum of a sequence, so that's with your sigma notation, like this. So a series is the sum of a sequence. Review from before, when you converge or a sequence converges, it approaches one limit, one number. If it doesn't do that, it diverges. So more vocabulary. A partial sum just means you're taking an infinite series and summing parts of it. So like here, if we plug in 0 and stop at 0, this would be a partial sum of 9. If we do 0 and 1, we get 9.99, 0 to 2, 9.99, etc., etc., etc. So these are partial sums of this series, which then you could assume sums to 10. As you keep going, you're going to keep adding on 9s until you get to about 10. So the convergence of a series converges if the values of its partial sum, so what we were doing on the last slide of like summing sums, adding the next chunk, adding the next chunk, approach a limit s or one number. It can be written like this. If it does not reach one number, it goes to infinity, it goes to negative infinity, it alternates back and forth, then it diverges. Okay, so looking at this, one of these converges and one of these doesn't. So what do you think? This first one, if we do 1, is your first partial sum, and then you do 1.5 is the next partial sum, 1.75, we keep adding them on, 1.875, and you're going to end up getting close to 2. So this one converges. If you look at this one, you have 1, and then you subtract 1, so you get 0, add 1, you get 1, subtract 1, you get 0. Back and forth, so you're going to go 0, 1, 0, 1, 0, 1. So this one diverges. Why is it tempting to say this converges? The reason being, it looks like it's doing the same thing over and over again. So it looks like you should get one number, but really you're alternating. To put it in perspective, suppose for the first one, I'm giving you a pound of gold, and then I give you half a pound, and then a quarter pound, etc., etc., etc. You'll probably stick around and end up getting more gold because you just keep gaining more. Versus this one, I give you a pound, I take it back. I give you a pound, I take it back. I give you a pound, I take it back. You're gonna get sick of that real fast because you're not really getting anything out of it. Okay, so things to come in calculus. You can decide if series converge or diverge. For example, this one diverges, but this one converges. We're not gonna get that complicated. So in this class, we are only gonna look at geometric series unless they're ones like we did at the beginning where you can plug some stuff in and kind of see what's happening. So think about this. Which of these cases will converge? Okay. This one is a yes because our sequences converge to 0, which means eventually you're adding nothing. This one's going to be no because here we're going off to infinity. Here we're alternating positive and negative. And this one is also no. The reason being here we go off to infinity, and then here we're alternating. Again, we're going positive, negative, positive, negative. Okay, so when will it converge? When your R value is a fraction. So negative a half, positive a half, negative a fourth, positive a fourth, all those kinds of things, when the absolute value is less than 1. What will it converge to? So this was our finite formula. So we know now that our r to the n, we're going infinite, so it's like r to infinity, and you know that your r is a fraction, so you have some fraction going to infinity, so this number is going to get really, really big, which then makes this 0, so it kind of cancels out, so this is your formula. First term divided by 1 minus your common ratio. So here it is all together. If you have an infinite geometric series that just keeps going on forever and ever and ever, it converges if the common ratio is a fraction. If it does converge, this is the formula to figure out what it sums to. So an example, here we have a pendulum swinging, and it's always going 2/3 of the distance. So your R is going to then be 2/3. For the previous swing, you pull it back, so your first swing is 9 inches. How far is it going to go in total? So if we write out our formula, we start with 9, and then we have a common ratio of 2/3 to our n minus 1. We're going to start with 1 and go to infinity. So your first term is 9, and your common ratio is 2/3. If you plug this into the formula, you get 9 divided by 1 minus 2/3, which will give you 27. And that's it for this. Check out Schoology to see what your homework is, but otherwise we're done.